Okay, for the next set of examples that is found up under the algebra and coordinate geometry part of the ACT involves actually solving for inequalities. And the only difference between an inequality and an equation, there are many differences, but the main difference is the number of solutions that is involved within the inequalities. When we're solving simple linear equations, we have one solution. When we're solving quadratic equations, we have two solutions. But when we incorporate an inequality symbol, less than, greater than, or less than or equal to, or greater than or equal to, now we put ourselves in a position where we can actually have infinitely many solutions. So one of the algebra techniques will still be the same as if we were doing equations, but there are a few things that we need to look at in particularly when solving the linear inequalities. Now, what I want to also suggest is I want to look at about 3 examples. I've also, we did about 5 or 6, 7 tutorials on actually how to solve and graph linear inequalities. We did not name it, it's not under the umbrella of the ACT, but if you look at those videos that just say solving and graphing linear inequalities, they're the same idea of what the ACT is actually asking for you to learn. So I'm only going to do about 3 of these examples, and I ask that you look back to the previous videos that we've done with solving and graphing linear inequalities. The first example that we would like to look at is that it says 3x minus 2 divided by 4 is greater than 2. And again, before I start working the problem, I ask that you go ahead and give yourself a minute to try to see if you can work this problem yourself. Pause the tutorial and then give yourself a minute to see if you can actually work through it. So we want to solve this inequality and we want to get a graphical representation for it. So the first thing that we want to do for these type of situations is let's eliminate our fraction. We can eliminate our fraction by multiplying both sides of the inequality by the denominator. So that way my 4's cancel out and I'm left with 3x minus 2 is greater than 8. So I have a 2-step situation here to do where I add 2 to both sides. 3x is greater than 10. And now when I divide both sides by 3, x is greater than 10/3, or we know this is 3 1/3. Now again, I hope that you're familiar with how to solve these 2-step equations. We're adding 2 to both sides because the inverse operation of subtraction is addition. The inverse operation of multiplication is division. So now in order for us to get a graphical representation, we put our number in question on the number line, which is 10/3, which is somewhere between the number 3 and the number 4, the integer 3 and the integer 4. Because this says that we want all solutions that are greater than 3 1/3. We don't want 3 1/3. We don't want 10/3. So that means that we would have an open circle above the number. And since we want all numbers greater than 10/3, well, we want to move our arrow to the right. Okay.